Hello everyone, my name is Waffle and welcome to the 9th episode of Strats Explained, Magically Easy, a video series where I explain how and why different strats and glitches that speedrunners use work. Today we are finally going to talk about mega jumps. This topic has been around since forever, it's been a part of all of the polls that I made, but it couldn't win for some reason, until today. If you are not familiar with mega jumps, then let me show you, in my opinion, the coolest one from speedrunning. And just like that, we travel from Portland to Staunton Island in a few seconds. This trick is used in all of the main categories of GTA 3 speedrunning. In some of them it is even the primary method of moving across the map. It is very hard to estimate how much time it saves. What you see right now is yet another mega jump. This time it's used to kill the player as quickly as possible. To do this trick yourself you have to attack using a weapon or while being unarmed, then jump and then play a replay right after that. It might look difficult, but it actually isn't. Just try it and you'll get it in a few attempts. But how does it work? Luckily for us there is an explanation from Nick, the link is going to be in the description. So we have a starting point. Walking, running, jumping, shooting, punching, throwing a grenade. All of these are animations, so it makes sense to start our journey from the class that implements them. It's called C-Anim Blend Association. There's a lot of stuff, but let me point out the most interesting things. First of all, Anim ID. This field contains an ID of an animation. This game has tons of them. Walk, run fast, idle. As you can see, there's actually more than 100. Okay, next. Blend amount and blend delta. These two are very important. But I'm going to be honest with you, even right now, I'm not exactly sure how these two work in all of the places where they are used. I believe that no one does. But as I said, they are very important, so I ask you to remember their names. Okay, the next clue we have. The glitch only happens when we use a replay. So, welcome to C-Replay Store Stuff in Mem. We are already familiar with this function from one of the previous episodes. But let me quickly remind you what it does. It basically saves your environment like vehicles, pedestrians, time, weather, etc. when you are starting to play a replay. And it does it so the game can restore everything back after the replay finishes. Okay, if we scroll a little further we'll see a for loop that goes over all of the pedestrians, and for every single pedestrian it calls store detailed ped animation. Let's see what it does. Okay, here we also have a for loop that goes from 0 to num main anims in replay, which is 3. I'm going to explain what a main animation is a little bit later. So, we get an animation and then we save blend amount. But as you can see we do it in an interesting way. Here's our original blend amount value, then we call some clamp. It looks like a function but it's actually a macros, and it basically says if the blend amount value is less than 0, then we return 0. If it's bigger than 2, then we return 2. Otherwise, we return the value itself. So this clamp actually does what it says. It clamps the value to the range of 0 and 2. Then we multiply that value by 255 and divide by 2. So basically multiply by 127.5. But why do we do all of that? Well, if we look at the original value, blend amount, we'll see that the type is float. And if we look at the variable where we are trying to save the value to, we see that the type is uint8, unsigned integer, which is only 8 bits long, and 8 bits is 1 byte. Floats are 4 bytes, so we try to fit a 4 byte value into a 1 byte variable. Obviously that's kind of impossible unless we somehow modify the value, and that's exactly what we do. Why do we do it? Well, back in the day, computers were not that powerful. So developers tried to minimize the amount of data they needed to save in memory. And if we do it here, here and here, trust me, it all adds up. Because we basically save 4 times less information than there actually is. Nowadays I don't think that anybody would care, but back in the day it was quite important. Obviously there is a price for doing so. Let's say we have a value of 0.5 and we want to save it. First of all, we multiply it by 127.5, we get 63.75. Then, since we are converting that value into an integer, according to the rules of the language, we have to truncate the value, so we actually save exactly 63. Now we want to restore the original value back, so all we have to do is divide by 127.5. We get 0.494 and some other digits, and obviously it's not exactly 0.5, but it's good enough for us, it's close enough, we don't care. Okay, what's next? Next we have a similar for loop that goes from 0 to num partial anims in replay, and this is 6. And yeah, as I said, it's very similar, so here's the same line of code for blend amount, nothing different. So when we start playing a replay, we save 3 main animations and 6 partial ones. When the replay ends, we obviously want to restore everything back. And look, there is an inverse function, retrieve detailed pad animation. It starts with a for loop that goes from 0 to num main anims and replay, and here's where we are restoring the blend values. We use the setBlend function. As you can see, it takes 2 parameters, amount and delta, and basically stores them back to blend amount and blend delta. Okay, it looks a bit weird, right? We, for some reason, don't even save blend delta, we just return 1, but that's alright, maybe? What's even weirder is this part of code, because we restore the modified, multiplied value, and that's exactly what is causing mega jumps. So to fix this issue, all we have to do is add division by 127.5, and boom, mega jumps are no more. Obviously you do the same down here. And that's where Nick's explanation stops, so thank you all for watching. If you enjoyed this video, leave a like, and if you don't want to... Wait, what do you mean you have more questions? What? What do you mean you want to know how this modified blend amount becomes our player's velocity? What do you mean you want to know why you can't literally run, jump and play and replay to do mega jump? Nick didn't answer these questions. And actually, when I asked him what is going on, he said that he has no clue. And then I realized I had to contact the person who reverse engineered this part of code, the one that is responsible for the animation system. So I contacted AAP and they said they don't know either. Well, actually, AAP answered a lot of my questions, which really helped me to get a better understanding of how all of this works, so I'm really thankful for that. Unfortunately, I still had my questions that I introduced a little earlier, so I had to follow Nick's suggestion and debug the code. Let me tell you how it went. The first question I wanted to answer was how does that blend amount value become our velocity? And after a little bit of digging, I noticed this function, cpad setJump. This function is called when we jump, and sure enough, here we create a jump animation or association with an ID anim std jump launch. Actually, in this game, jump has 3 different animations: launch, glide and land, but right now we are interested only in the first one. Then, for that created animation, we call setFinishCallback with finishLaunchCB. CB is short for callback. As you can see, finishLaunchCB is another function. So what's that about? What is a callback? Callback is a function that is going to be called later. When later? In our case it's very easy. Finish. So when the jump launch animation finishes, we are going to call the finishLaunchCB function. What's so interesting about that function, you may ask? Well, I noticed this variable, velocity from anim. By default it's 0.1, but if you have a sprint animation or a run animation, then it changes according to these 2 similarly looking lines. And as you can see, in both of them we use the original blend amount from the animation. And of course, if that blend amount value is modified, if it's 127.5 times bigger than it should be, then the velocity from anim is also going to be roughly 127 times bigger than the normal value is. Okay, what's next? Next we use that velocity from anim, we square that value and compare it to this monstrosity. What's that? Let's see. mvec move speed is a vector that contains three values, our current speed along each of the axes, x, y, and z. So we take that vector and we calculate its magnitude squared, but only 2D, so on a plane. We don't care about the z movement, the vertical movement at all. Why squared? Well, since we are using the Pythagoras theorem, we are going to get the squared value anyway, and after that we have a choice. We can either take a square root or square velocity from anim, and the second option is cheaper to compute, so we use that. Remember, it's all about these small optimizations. So here we basically calculate our current speed ignoring the vertical movement and compare it to the value velocity from anim. Obviously, if velocity from anim is modified, then it's going to be much bigger than our current speed. And in that case, we change the vector, the x and y, to that velocity from anim. Of course, there is a little bit of trigonometry to get the right values, but what we should understand is that our speed becomes much bigger than it should be, and that makes us fly. At least that was my theory, and to test it I had to use a debugger. What is a debugger? Debugger is the best friend of any programmer. What I can do is simply put a red dot right here, it's called a breakpoint. And what it does, well, when I launch the program, in our case the game, and when the game is going to execute this line of code, the execution is going to stop there, allowing me to investigate all of the values of all of the variables, including velocity from anim. And that was exactly what I did. If we just jump, then the velocity from anim value is 0.1, as expected, since we don't have a running or sprinting animation. Now, if we start running and then jump, then the value increases, but just a little, it becomes 0.17, so running doesn't really affect it that much. If we mega jump, however, then the value changes drastically, it becomes 8.99, so basically 9. And that proved my theory. However, I still had the second question, why can't we just run, jump, play and replay, and fly away? Why does it not work like that? So then I decided to check which animations get restored after a replay finishes in both cases. The sequences start the same. First we have run, then walk, then jump, and finally if we mega jumped we have partial punch animation. So far so good, everything looked fine there, so I decided to look at the blend amount and blend delta values. And I quickly noticed, some of the blend delta values were not equal to 1, they were negative. Moreover, jump launch animation had a negative blend delta value only if the partial punch animation was present as well. This felt weird. Let's go back to retrieve detailed pad animation. I'll remind you that first we restore all of the main animations, and after that we restore all of the partial ones. A main animation animates the whole model. A partial animation animates only part of it, for example, a hand. Okay, both of these have blend animation function, and the last parameter in these two is always 100. Let's see what it means. Okay, first of all, this last parameter is called delta. Let's remember that. What do we do here? We first get an animation using its group ID and anim ID. Then we have a for loop that goes through all of the already existing animations for the current model that we are working with. After the replay finishes, our player has only one animation, the idle one. I'm not exactly sure where it comes from, but it doesn't really matter. After that we add run, walk, jump, punch if we did a mega jump. Let's see how exactly we do it. First of all, we check if the animation that we want to add and the animation we are currently looking at that already exists on the model. If they both have the same anim ID, then we say, okay, we already found that animation and we work with that. But we know this is not our case, we always add new animations, so we always execute this branch of code. Here we have a check. If the animations that we want to add and the animations that we are currently looking at, if they both are partial or if they both are not partial, then we execute all of these. Here we first check if the blend amount value for the animation is positive, then we calculate blend delta. How? Well, we take a negative delta, so negative 100, and multiply it by blend amount. If that calculated blend delta is actually smaller than blend delta from the animation, or if the animation is not partial, then we overwrite animation's blend delta value with the new one. So for example, in our case, the run animation had a blend amount value of 127, so the blend delta becomes negative 12,700. That's obviously less than the blend delta of the animation, so we override it. And our run animation now has a negative blend delta value. What all of this means? Well, actually, all of this code means the following. Out of all main animations, only one animation will have a blend delta value of 1. The rest will be modified and will become negative. Same applies to all of the partial animations. Only one partial animation will have a blend delta value of 1. The rest will become negative. We can also say which animations will have blend delta of 1. These are gonna be those that were added last. So in our example, the last main animation that we added was walk, and the last partial animation that we added was either jump when we didn't mega jump, or punch when we mega jumped. And that's why the jump blend delta value is different in these two cases. The last thing that I want to show you in this function is add animation and sync. When we add a new animation, we actually add it to the start of the list because we prepend the value. And that's kind of important, because it means that those animations that we restore from the replay first are actually going to end up in the end of the list, and that order is going to be important a little bit later. It is quite obvious that all of the animations are updated on each frame, so here we are in SeaWorld process. There we have an interesting function called rp_anim_blend_clump_update animations. Let's see what's inside. Inside we have a for loop that goes through all of the animations, and remember, the order is always specific from left to right, and in our case it is partial punch, then jump launch, then walk, then run, and finally idle. In this specific order we call for each animation update blend. Here we add to the current blend amount the following value, blend delta multiplied by some time delta. If after that blend amount becomes negative or equal to 0, and blend delta was negative as well, then we call the callback if it existed for that animation, and delete this animation completely. And that was the final piece of our puzzle. Let me explain. When we work with the jump launch animation, if the blend delta for that animation is negative, then blend amount will become negative on the very first frame after the replay, and we will call the callback, and as we all remember, in that callback we are going to use the modified blend amount value of the run animation, and therefore we will get that incredible speed. However, if the blend delta value was equal to 1, then blend amount will not become negative on the very first frame. Obviously it will become negative eventually, but not on the very first frame. So we don't call the callback, we don't delete the jump launch animation, we continue as normal. But next we update the run animation, and we know that blend delta for the run animation is always negative in our case, which means that blend amount for that value goes negative 2, and we delete that run animation, so therefore we cannot use the modified blend amount delta from it anymore, it doesn't exist. And this is, ladies and gentlemen, how mega jumps work. So, to make a mega jump work, we have to make sure that apart from the jump launch animation, we have at least one other partial animation that was played before the jump animation. That will ensure that the blend delta value of the jump animation is going to be negative, which means that on the very first frame after the replay finishes, this jump animation will be deleted and the callback function will be ran. And inside of that callback function we use the blend amount value from the run animation, and we know it's modified, it's 127 times bigger than it should be, and that increased value is used to calculate velocity from anim, which is later used to modify our player's speed. Whew, it was hard to even just say it, let alone understand. This was by far the hardest topic in this series. And I bet you still have some questions, so please, don't be shy, ask them and I'll happily answer them. I went to the speedrunning server and asked people to name all of the ways to trigger mega jumps they knew. In the first answer I got a very well known and quite popular double jump method. Here we use jump length as the second partial animation. And with our current knowledge we understand that we don't even have to jump at all, it's enough to step off a small fence or even a car and mega jump this way, it will still work. The other suggested method was unknown to me and boy oh boy it looks goofy. Unfortunately it was the last suggested method, which actually helped me to come up with today's challenge. All you have to do is come up with new mega jump methods. There are a lot of partial animations in this game, you just have to find those that can be combined with a jump. Test your methods in game, suggest them in the comments, and if they work, you'll receive a heart. Good luck! Personally, my favorite method of mega jumping is with the middle finger animation. What we've covered today was only the tip of the iceberg. I was told that there are a lot of methods that don't require playing a replay at all. What's even weirder is that in some of them mega jump happens with some other pedestrian, not even our player. And to this day these anomalies haven't been explained. Look at this one for example. Do you know what happened? I don't think so. But enough horrors for today. A poll for the next topic is going to appear on the community tab in roughly 3 days after this video is released. I will also put a link to it in the pinned comment. Thank you all for watching. If you enjoyed this video, leave a like, and if you don't want to miss the next episode, consider subscribing. My name is Wofil, see you the next time.